Sometimes it is important to set aside equal-sized bins, as we did on the last tab with histograms. Your author gives us a formula that will do this for any set of data. Let's first create the bins using the data, and then we'll try to understand the formula better. I've clicked here on H5. I'm going to copy everything except the single quote, escape, and I'm putting it into all of the bins, highlighting all of the bins. This is a multiple cell array, and so I'll paste it in and do Control-Shift-Enter. Now we see bins of equal size, 10 of them, from 50 through 500. Let's try to understand why it built that size of bin by looking at the formula. We'll come up here to Formulas. Let me just click on one, Evaluate Formula. And you can see we have the minimum of data. Well, this is our data over here. So it says A2 through E21. The minimum amount we find in there is 1. We see that in B6. Now it says indirect the row, one of the rows between 1 and 10. It'll put different amounts in here depending on what row you're in. In the first row, it will take 1, second row 2, and so forth. So we evaluate the indirect rows 1 through 10, and right now we have 1. Times the maximum of the data. So the minimum of the data we already got. Looking through the data, the maximum was 500. We can see that in cell B11. Now we want the minimum of the data. Again, that's in B6, was 1. So that's 499, the difference. We add 1 to it. And now multiply that by which bin we're looking at. In this case, the first one, so 1 times 500, divided by the total number of bins, 10. It says, oh, well, each bin size will be 50. And then we add on the minimum and subtract off 1, and we show the 50. So that was nice where it was an even number like that, every 50 between 1 and 500. But let's see what happens when we change this 1 to a 10. Now we get different sizes of bins. Let's maybe put these so that we can see them as like that. Okay, let's try it again now and see how it got this size of bin. Each bin is 54.5, still going up to a total of 500, which was our highest cell over here. So we go Formulas, Evaluate Formula. The minimum is 6. You can see 6 down here in D17. Indirect rows, it'll still show 1 right now. The maximum of 500 minus that minimum of 6 equals 494 times 1 plus 1, 495 times 1, and then we divide by 10. 49.5 is the size of each bin. We then add the 6 to it where we're starting from, 55.5, and subtract 1, and each bin is 54.5. That's where we start at, and we keep adding those up, and by the time we get to our 10th bin, that will be the 500. This way it can handle any combination of data depending on the lowest value and the highest value and set up 10 bins that accommodate that data.